Alright, welcome to today's Stochastic Processes class. My name is Sondolo Afemi Bodobe. So in our last class we do a quick revisions of what a sample space is, what a random experiment is, and then what a random variable is. So today and also last lesson we also check what a stochastic process is. Then we also check the state space. Alright, so if you are not taking your time to watch that, I just urge you to do that. So make sure you go through that in order to have a basic understanding of what you want to do. Alright, today I'll be talking on this. Today's what you just want to do is to not classify the types of stochastics process we have. But before then, I want us to check these 4 examples. With the aid of these 4 examples, we're able to know the types of stochastic process we have. We're able to classify it based on 2 parameters that you are going to check shortly. Alright, so let's go to this first example. We say let xn be the outcomes of the nth toss of a 6-sided die. Alright, so the state space, very important, is, take note of this, that is the state space, that is the possible outcome of that experiment, the possible outcome of that our random variable experiment. So it is 1, 2, 3, 4, 5, 6. So take note of this state space. In our last class also, I classified the 2 types. I mentioned the 2 types of state space we have. We have a discrete state space and a continuous state space. So we can also check that later on. So this state space we have, we can actually know the number of members of elements we have here, which is 1, 2, 3, 6. So this is a discrete state space because the members are countable. It's not uncountable, it's a finite set. This state space is a finite set, so that makes this state to be a discrete state space. Okay, it's as and our number of variables times we want to check, that is 1, 2, 3. What does this example try to mean? That is, we want to check what will be the outcome of tossing a 6-sided dice. Once we toss it first time, the second time, what will be the outcome? The second time, what will be the outcome? The third time, what will be the outcome? That is xn1, xn, x subscript 1, x subscript 2, x subscript 3. So let me write that out. We want to find x subscript 1 when n equals to 1, comma, when s equals to 2, when s equals to 3. Now we are not solving the example, we just want to understand what a stochastic process is and the classification of stochastic process. So now this system, this model is trying to postulate that what will be the outcome of this our system, which is a die. If we toss a die the first time, what will be its state? We need with the face that is going to show, will it be 1, will it be 2, will it be 3, will it be 4. Then after that again we go another second round, which is x2, we toss it again, another round we toss it 3 times. So here now for this state space we have a discrete, as I mentioned earlier, discrete state space, and then the number of the nth times that wants to perform the experiment is 3 times. That is, want to check x1, x2, x3. Is that taken? So because this stochastic process is countable, is finite, it is not uncountable. So that makes this example to be a discrete, because this nth time is discrete, is countable. That makes this example to be discrete stochastic process and processes. Sorry, discrete process, and then because of this our state space, which is also discrete, so we now classify this example based on these 2 parameters, based on the value of x, the state space, and the number of times, nth time, that we want to perform that operation. So we now call it discrete time, discrete stochastic process, and discrete time state space, discrete state space. So this example is discrete stochastic process because of this nth time, which is finite, and discrete state space because of this state space. So that is the first example of, that is the first classification of stochastic process based on the value of x and then on the value of n. Please take note of that. So let's share the second example. For the second example, now we have let x subscript n be the temperature in degrees Celsius recorded at unknown airport at 12 noon on the nth day. The state space of this stochastic process is x minus 10, 60, and n equals to the number of times 1, 2, 3, dot. So let's try to analyze this example, then we're able to classify this particular stochastic process. Alright, first thing, let's find out our the state space we have. Okay, let's first of all deal with the nth time. So look at this now. The value given here for our n, that is 1, 2, 3, dot. In other words, this is infinite set. That is, we have to find the temperature of that airport at x1, at x2, that is at when time is 1, after 1 time, after 2, maybe if the time is in seconds, maybe after 1 second, after 2 seconds, after 3 seconds, and after dot. So this is infinite. So this makes this stochastic process to be, because it is infinite, to be continuous, and that will be second type of stochastic process we have. Because of this n, which is infinite, so we have continuous stochastic process. And so let's consider the sample space we have now. So here we only have 2 elements in this our state space rather. So we have minus 10, that is, it is very cold, it's below freezing point, and 16, this is very hot. So we only consider 2 state space for our temperature, which is minus 10 and 60. So because this state space is discrete, so that makes this the full name, the full classification of this example will be continuous stochastic process and discrete state space. I hope you get the trick now. So let's move to the next example. We analyze it and then we also classify it based on the value of x, the state space, and also the value of n or t as the parameter, or as the case may be. So look, we have let x subscript t be the value of a stock at time t. Then the state space is 0, infinity, and t is 1, 2, 3. So let's analyze it now. So here, take note of this and this. These are the state space and the t, which is the domain of our time, or of the number of stochastics, of the number of time we want to find. So if we look at this our state space, so if we want to write this is equals to 0, infinity, which is equals to x, such that x is less than or equals to 0, because this is a closed band and this open band, less than infinity. So we can see that this state space is not discrete, rather is continuous. This is a continuous state space. And let's look at this, our domain T. This is 1, 2, 3. So we only have 3. Remember that if you have to look for at x1, x2, the state at t1, the state at 1, the state at 2, the state of the system at 3, only 3 times. So this is a discrete stochastic process. So if you want to classify this now, that will be classification 3. This is discrete because of this, which is discrete. We have discrete stochastic process, and the state space now, which is continuous and continuous state space. Don't worry, I have the example list, I have the classification listed below. Just take note of that example. Alright, let's share the last example, and I'll give you the last classification based on X and T. So let X subscript T be the temperature in degrees Celsius recorded at unknown airport at time T. Then the state space of our stochastic process is this. Our state space is closed boundary between the range of 0 and infinity, and then our time domain is 0 and infinity. So sure, if you are conversant with interval, you should know that this our state space is continuous, and this is continuous state space, and this is continuous time domain. So because of this, we have stochastics. That will be classification 4. Stochastics. That should be continuous stochastic process. So we have continuous stochastics process, and the state space now, which is discrete. No, it is not discrete. Continuous, and continuous state space. So you can now check the classification of stochastics based on the state space and the domain of T. First is discrete time and discrete state space. So if our domain is discrete, then we have discrete time and discrete state space. Also we have discrete time and continuous state space. We also have continuous time and discrete state space. We also have continuous time and continuous state space. Alright, thank you for watching. I would love to see you in the next lesson. Alright, my name is Sondolo Afem Golibi. Thank you.